All right, 7.6a, page number 628, last section of chapter 7. And we're going to get into some kind of strange stuff, but it's really not too terribly scary, although the graphs in the 7.6 look a little bit weird. So anyway, let's go ahead and get started with this. Now, these are inequalities. That means instead of ax squared plus bx plus c equals 0, we're dealing with ax squared plus bx plus c is less than 0. It can be less than or equal to 0, greater than 0, or greater than or equal to 0. So we're looking at numbers to put in for x that will make this less than 0. This, when we put all the numbers together, less than or equal to 0, greater than 0, greater than or equal to 0. All right, so one of the things that's important is that this a will never be 0, because if it's 0, it quits becoming a quadratic equation, because 0 times x squared, no matter what x is going to give you 0. So then pretty much we're just left with bx plus c, which is not a quadratic equation or inequality. So now that we know that, let's get rid of all of this. And in fact, let's just get rid of all of this and start. So if we have a quadratic equation like this, and we say that when we put the number in for x, square it, subtract 6 from it, we're going to come up with a number bigger than 0. Not 0, but bigger than 0. Okay? So there are an infinite number of x values that we can put in here that would make that a true statement, supposedly. So that's what we're going to look at doing. So what we're going to do first of all is we're going to factor. So we're going to factor this into two binomials. And when we factor it, it's x minus 3 and x plus 2. Okay, therefore, x is going to be equal to 3, or x is going to be equal to negative 2. So those are my options there for x value. And let's just look at this again, because if x is 3, then we get 3 minus 3 times 3 plus 2 is greater than 0. So 3 minus 3 is 0 times 3 plus 2 is greater than 0. So is this greater than 0? No, because 0 times 5 is equal to 0. It's not greater than 0, but 0 is not greater than 0, but we at least know our starting point, okay? Because any number bigger than 0 is going to make this a true statement. So anyway, just to remind you of how that works, let's go back up here. And what we're going to do, I'm going to kind of ignore a couple of the things the book does, but I'm just going to draw a number line. And I'm going to put the numbers we get for an answer. So first of all, I'm going to put 0. Then I'm going to put negative 2. And then I'm going to put 3. Okay? And what I'm going to do with those, I'm going to draw a line here. Whoops, that wasn't where I wanted the line to go. It's got to go through 3 and through negative 2. All right, so let's erase this so I have a little more room. Sorry for my sniffling. I'm still fighting a cold. All right. A couple things that are really, really important when you're looking at these is we've got a number here times a number here, and that when we multiply those, we have to get a number greater than 0. Which means when we multiply these two, we have to get a positive number if it's going to be greater than 0. Well, in order to multiply two numbers to get a positive, there's two different options. A negative times a negative gives me a positive number, or a positive times a positive gives me a positive number. So those are my two options there. Okay, either both of these, when I take x minus 3, I've got to get a positive number, x plus 2, I got to get a positive number, so that when I multiply, I get a number that's positive and greater than 0. Or when I put a number in here and subtract 3, I get a negative, and when I put that number in here, I also get a negative, so that a negative times a negative is a positive, which is greater than 0. So that's what I'm looking for. Two values I can put in here for x that when I multiply, I get a number greater than 0. So let's look at this. Let's look at numbers that would make x minus 3 give me a positive answer or a negative answer. Okay, so if I put a number like 0 in for x here, I'd get a negative 3. So that tells me that any number to the left of negative 3 on the number line would give me a negative number. So if I put negative 4 in here, I'd get negative 4 minus 3, which is negative 7. So anything to the left of 3 is going to give me a negative symbol. And these are negative signs, okay? To the right of my 3, let's see what I have. Let's put in a positive 5 here, and we'll put that in here. 5 minus 3 is a positive 2. So anything to the right of 3 is going to give me a positive answer. Okay? You don't really have to understand what's going on yet. Just know that we're going to make one row of my x minus 3's. I don't care what my answers are, but they're going to be negative answers to the left of 3 and positive answers to the right of 3. All right, now let's look at x plus 2. All right, so to the left of this red line right here at x minus 2, what do we get? If we put a negative 4 in for x, negative 4 plus 2 is negative 2. So anything over here is going to give me a negative. If I put a value, let's say I put 0 in, 0 plus 2 is a positive 2. So everything over here is positive. Now let's look at the other side of this red line, which shouldn't really matter. Let's put a 5 in there. That also gives me a positive. All right. So at this point, what I've come up with is that to the left of this sign, when I add any of these values to the left, negative 4, negative 5, anything smaller than negative 2, and I add it to 2, I'm going to get a negative number. Any number to the right of negative 2, I'm going to get a positive number. So let's say I picked negative 1. Negative 1 plus 2 is positive 1, so I'm getting positive numbers. All right, one of the things I said is that I am interested in two numbers multiplied together give me an answer greater than 0, which means, like I said, either both of these numbers have to be positive so that when I multiply them, I get a positive number, and all positive numbers are greater than 0, or a negative number here and here, because two negatives give me a positive, which is going to be greater than 0. So those are my options. Fortunately, looking at this graph, I can say, oh, all the numbers smaller than negative 2 are going to give me negatives. Two negatives give me a positive. Here's a negative and here's a negative. Two negatives give me a positive. I look over at the other end. Two positives give me a positive. So what that tells me is that I can pick any number less than negative 2. Any number over here and any number over here. And when I plug it in here, I'm going to get a number greater than 0. So let's try one. Let's try negative 4. So negative 4 minus 3 times negative 4 plus 2. And I'm saying that's greater than 0. Negative 4 minus 3 is minus 7. Negative 4 plus 2 is negative 2. 7 times 2 is 14. Two negatives give you a positive. Is 14 bigger than 0? Yes, it is. So that works. Let's try the other side. Let's try putting 5 in. 5 minus 3 times 5 plus 2. And again, I'm taking that from over here. So I get 2 times 7 is greater than 14. Okay, so a positive answer when I did it there, a positive answer when I did it there. That's all I care about. I just want to know what, I'm not looking for the value of x. I'm just looking at the possibilities of x. So the possibilities that x can be, get rid of all this here, are all numbers less than negative 2, which would include everything here, and all values greater than 3. These two are my answers. That's what I'm looking for. Any number I put in here for x, any number I put in here for x, as long as it's greater than 3 and less than negative 2, is going to make this a true statement. Okay? So that's kind of a long, drawn-out process to do this, and hopefully, if you're confused, doing the next few examples, we should be able to hopefully get this under our belt. So I am ready for example 1 on page 630, and we'll save that for the next video.